When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot express it in numbers, your knowledge is of a meager and unsatisfactory kind. This was said by Lord Kelvin, British scientist, physicist actually. So what does it mean? It means measurement is necessary. If I say that this is very good or this is very bad, we don't know how much it is good or how much it is bad. So that's why it is the quantitative requirement is very necessary, not just qualitative. So that's why measurement is necessary. Okay. Now, see this person. This is Charles Edward Spearman. He was a very famous British psychologist, and he worked on human intelligence, and he invented actually the method of factor analysis during the First World War. So he was not a great psychologist, but also he was a great statistician, because many psychological analyses are based on statistics. And there is a very famous journal which is named as Psychometrica. Okay, very renowned journal on psychology. Okay, so that journal particularly focuses on the statistical aspects which are applied on the domain on psychology. So it is a very, very crucial to know statistics well if you work in the field of psychology. So today we will start the structural equations model. Okay. So why I made these quotations? Because structural equation modeling is actually based on the factor analysis, because in structural equation model, one part you will find which is based on factor analysis, okay, or confirmatory factor analysis. And another thing is that in structural equation model, the basic objective of the structural equation model is to find out the relationship between the latent constructs or the unobserved variables. Okay. I have previously told you, suppose I have environmental proactivity, one variable, which is unobserved. You cannot observe it. And another is suppose financial performance. That is also another unobserved variable. And under financial performance, there are some manifest variables which can be directly observed. And under environmental productivity, there are some manifest variables which can be directly observed. Okay. So our intention is to find out the relationship between the unobserved variables like environmental productivity and financial performance. So that will be done using the structural equation modeling, or simply it can be also said as structural model. So structural equations modeling is a family of statistical models that seek to explain the relationships among multiple variables. To do so, it examines the structure of interrelationships expressed in a series of equations similar to a series of multiple regression equations. These equations depict all of the relationships among constructs, the dependent and independent variables involved in the analysis. Constructs are unobservable or latent factors that are represented by multiple variables. So basically it is based on the multiple regression. Okay, so that's why I told you that the regression is very important to understand, because structural equation modeling, it's nothing but it's actually based on the regression model. Okay, so and obviously hypothesis testing. Okay, so let's take a look at this thing. The basic things in structural equation model, two different models are merged. One is a measurement model or confirmatory factor model, and another is path model or structural model, which is based on multivariate regression or multiple regression. Okay. So there are two parts we will discuss today. We will discuss the confirmatory factor model part or confirmatory factor analysis or CFA part, and in the next classes we will go through the path model or the structural model. And some symbols also you need to know. These are some signs. This is xi symbol, this is zeta symbol, this is gamma capital. There are other symbols as well in the structural model, general model of structural equation, but those symbols you already know, those are very common, but these symbols are not very commonly used. Okay, xi, zeta and gamma capital or uppercase. So that's why these symbols I have provided. So CFA, confirmatory factor analysis, and the ACM both have also, there are some steps. Okay. So what are those steps? Those steps are actually, one is the first step is model building. The second step is model identification. The third step is parameters estimation, and the fourth step is model validation. These things are there under the confirmatory factor model. Okay, so let's take a look at that, how these are actually defined or described. Okay, so this is the first step. Okay, the first step is that the model building. This is the basic or the most important step, because based on your model you will do all the calculations. So model building is the first step, and this is the most important thing. Okay, so here in this diagram, this is please note it, this is very useful for your research work. Please note it meticulously, carefully listen. See, these variables, okay, these variables which are represented in circle, they are termed as constructs. Okay, that means they are unobserved variables. Okay, they are unobserved variables, or these are known as constructs or latent variables. So latent variables, constructs, or unobserved variables, all are same thing. Okay. Now, and these are represented with circles. Okay. And these variables, which are represented rectangular shape, okay, these boxes, x1, x2, x3, x4, y1, y2, y3, y4, these variables are known as manifest variables. Okay, or simply speaking, they are variables because they are observable variables, because they can be directly observed, and whenever you will do the survey, you will actually take data of this x1, x2, x3, x4, x5, x6, y1, y2, y3, y4. These data you will be actually collecting in the form of survey, okay, for different samples. Okay, and you will be ultimately finding out all these terms. Okay, these all these terms you will be finding out. What are these terms? You can see here that sigma 1, sigma 2, sigma 3, sigma 4, these are error terms. Okay, and epsilon 1, epsilon 2, epsilon 3, epsilon 4, these are also error terms. You can see here that the eta 2, not eta 2, this is zeta 2, and here there will be zeta 1 actually. So zeta 1, these are actually known as the error terms. There will be obviously error terms. Why? Because, or you can say that I mean, here you are actually saying that they are error terms, but technically speaking, you will be basically calculating the residuals, because you will be dealing with the samples. Okay, so your predicted value will not be exactly matched. That's why this error terms, or these residuals actually exist. Now you can see that there are also lambda terms. Okay, there are also lambda terms. Different lambda terms are there. These lambda terms are actually known as the loadings. Okay, these are nothing but the correlation between the observed variables and the unobserved variables. These are known as loadings, and you will be finding out, your major intention is to find out the relationship between these variables, these unobserved variables. Okay, so all these parts, so you will be actually, your main intention is to find out the gamma 1 1, gamma 1 2, gamma 2 2, gamma 2 3, like that. Okay, because these are actually representing your hypothesis. Okay, so this is the main intention. Okay, these things you will obviously calculate, but your main intention is to find out this. So you can see that there are, this part belongs to, this part is known as the independent variable, and this part is known as the dependent variable portion. Okay, you are collecting data of the x's which are independent variable. So these unobserved variables, they are also representing the independent variable, and here these variables, they are actually representing the dependent variable, and you are also getting the data from the dependent variables. These data you are also collecting. Okay, so basically it looks like this. There are this kind of parts. This is this part, this is one part, this is one part, and this is another part. Okay, so these parts are basically known as the measurement model, where you will do the confirmatory factor analysis or CFA. Okay, and this part is known as the path model or structural model, because you will be finding out the path coefficients. Okay, these coefficients you will be finding out, the path coefficients. Okay, and these independent variables are also known as exogenous variables, and these dependent variables are also known as the endogenous variables. So exogenous variables and endogenous variables. Okay, and now have a look at the equations for structural equations and the measurement equations. Okay, what is structural equations? Say for the eta 1, you are finding out. How can you find out eta 1? Eta 1 is given by, just notice that the symbol of this arrow, how it is influenced. The equation will be represented by how the variable is being influenced by the others. You can see here the coefficient is gamma 1 1. So put here gamma 1 1, and this is coming from xi 1. So put here xi 1 plus gamma 1 2 into xi 2. Okay, xi 2. This is resulting plus here zeta 1. What zeta 1 will be there? Here it is missing. Actually, there will be zeta 1, which is the error term. Okay, so you are putting here that. Now notice eta 2. Eta 2 is equal to, you can see that gamma 2 2 is there. Gamma 2 2. It is coming from xi 2. So gamma 2 2 into xi 2 plus gamma 2 3 into xi 3. Okay, this is being influenced, plus beta 2 1, because eta 2 is also being influenced by eta 1. So beta 2 1, this into eta 1 you should write, plus zeta 2. Okay, zeta 2, this is error term. So in this way you will represent. So ultimately this is the general form. In terms of the matrix form, you can represent it like this. The general eta 1, eta 2, eta 3, like that you can represent it as eta is equal to, this is gamma, this is all the gamma 1 1, gamma 2 2, gamma 3 3, all these things in the matrix form you can represent at the capital gamma. The xi 1, xi 2, xi 3, xi 4, all those things you can represent at the xi in matrix form, plus and also these values gamma 1 2, xi 2, these things also represented by these things. Okay, in matrix form you will write, the matrix will be like gamma 1 1, gamma 1 2, gamma 2 2, gamma 2 3, like that. And then xi 1, xi 2, xi 2, xi 3, the matrix form will be like that. Then beta term will be there, eta term will be there, plus the zeta term will be there. Okay, so this is the matrix form. This is for the structural equation model or the measurement, or the path model. Okay. Now, this is actually basically the second part. The first part is the measurement model or the measurement equation, which is known as also confirmatory factor analysis model. So here it is represented by matrix form. X1 is equal to lambda, capital lambda x into xi plus delta. Okay. So you can represent it like small x1 is equal to, okay, the here the lambda terms, all the lambda terms, small lambda terms you will write. Then the xi, okay, because the direction of arrow is this side. So here you will represent xi1 or xi2, whatever be, plus these terminologies, sigma 1 or sigma 2. So in this way, there will be many equations, x1, the equation for x1, the equation for x2, equation for x3, x4, x5, x6, whatever be the variables you will write. Similarly, in case of y, you will write y1, y2, y3, y4, so many variables. Then lambda terms will be there. The matrix will be lambda y11, lambda 2, 3, like that. All terminologies will be there, and it will be also represented. Will be influenced by eta 1, eta 2. Okay, and also there will be epsilon terms. The error terms will be there. So a lot of y1, y2, y3, these types of equations you will be getting. Okay. And in here also, suppose it may be instead of these two terminologies, there can be eta 3, eta 4, eta 5, eta 6, lot of terminologies you can have. The direction of arrow may vary depending upon the structural model. Suppose if you want only to check how xi1 affects eta 1 and how xi2 affects eta 2, then there is no need of this line or this arrow. Or suppose if there are some other variable, or suppose if you want to find out that how xi1 affects eta 2, then you will make another arrow, that xi1 how it affects eta 2. Okay. So depending upon the requirement, you will be dealing with all the you will be actually dealing with all the you will formulate your the diagram. Okay, you will formulate your figure, and this is actually the procedure of model building. Okay, this is the procedure of model building. So have a look at another example. Here you can see that this is another model, work injury. This is here, it is the unobserved variable, and these are all the observed or the manifest variables. And under the construct of suppose safety environment, there is safety training, safety practice, SIM. Under the work hazards construct, there is physical hazard, production pressure, like this. There are different things are there. Okay. So in this case, here you can see that you are interested only to see this kind of relationships is there. Okay. So now there are some reflective and formative constructs. Okay. So reflective formats, if you have a look at, suppose here you can see that the direction of arrow is actually changing. Okay. Here you can see that this is your unobserved variable, and from here the direction of arrow goes towards the observed variable. Okay, so this is known as the reflective constructs, and this is actually known as the formative constructs. Okay, because suppose the direction of arrow from the manifest variables towards the latent variable or construct. Okay, so this type of reflective thing, it actually exists in case of the structural equation model, because you will always find that the direction goes towards this. Okay, because you will be collecting these data and you will be actually expressing you will basically you will group in confirmatory factor analysis, just like the exploratory factor analysis. You have seen that I have previously told you that in case of principal component analysis, you group some particular variables. So the direction of arrow in case of principal component analysis, it is the reverse direction. Okay, because you are grouping some variables, but it's not necessarily that the thing will be something meaningful. Okay, but here in this case, it is not like that. In confirmatory factor analysis model, you will have some hypothetical factors, or in case of exploratory factor analysis, there will be some hypothetical factors, and here you will not have some hypothetical factors, rather than you are having some factors like xi1, xi2, xi3, which are based on your literature review actually. Okay, if it was confirmatory exploratory factor analysis model, then the direction of arrow and the lines would have been from xi1 to x1, x2, x3, x4, x5, x6. All these arrows you would have got. Okay, from xi2, the direction of arrow would have been x1, x2, x3, x4, x5, x5. In all this direction, you would have got those arrows, because you didn't know that which particular, because all those factors are hypothetical factors. So which particular factor will be related to which particular variable, prior you don't know about it. But in this case, since you have done the literature review, you already know that which are related to or which are associated with which particular manifest variables, which particular construct is related to which particular manifest variables. Okay. So the first step is model building. This is very important. Now the second step is model identification. Okay, model identification is the second important thing. So in model identification, first you need to check the order condition, then we will discuss the rank condition. Okay, this is the second step. First model building, then model identification under confirmatory factor analysis model or the measurement model. Okay. So every path correlation and variance is a parameter. Now the thumb rule is that the number of parameters cannot exceed the number of data points. Okay, if so, your model is under identified and cannot be estimated using SEM. So data points are calculated by, the formula is P into P plus 1 divided by 2, where P is the number of observed variables. Suppose if you put here 3, then it will become 3 into 4 divided by 2. So 12 divided by 2 it will become 6. Okay, so what is this thing? Just have a look at this diagram. Suppose this is one construct, unobserved variable. Under this, there is some manifest variables. Okay, you can directly find out the data of the manifest variables. There are two error terms. Okay, these two loadings are there. So ultimately, how many parameters you need to estimate or find out? You need to find out 1, 2, 3, 4. These two loadings and these two error terms or the residuals that you need to find out. Okay. Now, how many data points are there? There are, so 4 parameters are to be estimated. And since there are 2 variables, okay, so there are 2 data points. Now you put this formula, you put 2 because P is the number of observed variables. So put here 2 to calculate the number of data points. Okay. So the data points are 2 into 2 plus 1 divided by 2 is equal to 3. 2 plus 1, 3. 2 into 3, 6. 6 divided by 2. So it is 3. So the number of data points, it is 3. And the parameters that you should estimate, that is 4 parameters. Okay. So how can you find out the values of 4 parameters with 3 data points? It is mathematically it is not possible. Okay, it's just like suppose if you have if you are given suppose 2 equations and there are suppose 4 variables you need to estimate x, y, z, n. Okay, and suppose if the value of some variable is not 0, then how can you find out the other variables? It is not it's not possible. So it's just like that. Okay, now suppose instead of 2 variables, if there are 3 variables, then see that how what happens. Then there will be 1, 2, 3. Okay, 3 loadings will be there, 3 error terms will be there. Okay, so 3 plus 3, 6 parameters you need to estimate. And what will be your data points? You put here 3, the number of variables. 3 into 3 plus 1 divided by 2 is equal to, it will be 6. So you have 6 parameters and you will have 6 data points. So you can find out all the values, but this is known as 6. Since both the cases it is 6, so this is known as just identified model. Okay. So in order to perform structural equation model, your model must be just identified, at least just identified model, or over just identified model. If you have 3, 4 instead of 3, if you have 4 variables, you will be estimating 8 parameters and there will be many data points greater than 8. So you will not face any kind of problem and your model will be over identified model. So that's why it is always said that when you perform the structural equation model under one particular construct, you should have at least 3 variables. It is preferred. Okay, under one particular construct, at least 3 variables will be there for this particular case. Okay, so this is actually required, or it is actually desired. Okay, now take a look at this example of case study, confirmatory factor analysis. Another case you look. Here you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 constructs are there. Okay. Under 9 constructs, there are 18, a total of 18 manifest variables and 18 error terms also exist. Okay. So here you need to find out, first you find, how can you find out that how many parameters you need to estimate. Okay. So there are 18 error terms. So you need to find out 18 error terms. There will be 18 lambda values, 18 lambdas you will be finding out. This is, and also you need to find out these correlations. Okay, how many correlations are there? The formula is m into m plus 1 divided by 2. So since there are 9 constructs, so put here 9 into 9 plus 1, 10 divided by 2. So it will come out to be 45. Okay, so put here 45. So it will be 81. So 18 plus 45 plus 18 is equal to 81. Okay. So the you need to find out a total of 81 parameters. Okay. And how many data points are there? Since there are 18 variables, you put here the formula, earlier formula 18, you put here 18. So 18 into 18 plus 1 divided by 2. So it will be come out to be 171. So you can see that the number of data points is greater than the parameters you need to estimate. Okay, 81. So the model is over identified model. Okay. So now we will discuss the model estimation part. In model estimation part, certain things we need to find out. One is obviously the correlation matrix. Okay. This is for all the variables, the correlation matrix is there for 18 variables. And here all the, suppose all the constructs, those the correlations based on the construct that is provided here. So these things, from this matrix we can understand that the association, we can understand that which particular variable is closely related to those things. These things are actually we can understand the correlation coefficients, all the correlation coefficients we need to find out. And usually this thing is performed in any paper you will see when they perform some structural model, they do those things. But the main thing is here that you need to, based on the model equations, okay, you will be finding out all the lambda values. It is now less than 1 minute, so we can rejoin again. So you can see that all the lambda values they have found out first. Okay, so these lambda values we have got. Okay, so all the 18 lambda values or the loadings, those have been found out using the structural model, and this will be automatically generated by the software. You don't need to worry. This will be automatically generated by the software. Whatever software you use, these loading scores will be